All right. Hello, everyone. Welcome back to Comp 2150, Object Orientation, otherwise known as the course that you do your 2080 and 2280 homework in. Yeah. The end of the course is coming really fast. Like we're really close to being done the term. And I mean, I don't know about you, but I'm thrilled about that. I'm really happy. I'm really happy. I like seeing you all, but I'm going to be happy not to see you again for a while. This week, we are looking at multiple inheritance. So we're kind of like looping back to C++ a little bit, but kind of purely in the academic sense. It's something that you could expect to be on the final exam, but it's not something we're expecting you to program. We're going to be talking about multiple inheritance this week. And then next week, my plan is to have kind of a review class. So there won't be any new material next week. It will mostly just be reviewing material. And then I guess time for like questions for the assignment and stuff like that. It will be like really last minute questions, but there'll be time for questions for the assignment. I'll talk about the exam next week. I'll just talk about the exam next week. That will be what we'll talk about on Tuesday next week is the exam, because that's kind of like the end of the week sort of thing. So, all right, with that, let's talk about what we're going to talk about today. So the goal here for today is to talk about the idea of multiple inheritance. And we're going to be looking at this in two different ways, in two different languages. We're going to first look at the idea of simulating that something that resembles multiple inheritance with Java and interfaces. We're not actually doing multiple inheritance with Java and interfaces, but we're getting close to the idea of multiple inheritance with Java and interfaces. And then we're going to look at actually doing multiple inheritance in C++. We're going to see some of the consequences of starting to try to do things that look like multiple inheritance in Java, and then not really spend a lot of time talking too much about them because Java doesn't let us actually do multiple inheritance. And then we're going to talk about the real consequences of using multiple inheritance in C++. Next class, we're going to talk about a different form of inheritance called virtual inheritance. And virtual inheritance is something that kind of gets bolted onto C++ because of some of the consequences of doing multiple inheritance in C++. And it changes the way that subclasses interact with their superclasses, specifically in terms of I've got multiple parents that may have a common ancestor, and how do I deal with data issues and method issues that come between those things. So virtual inheritance is what we're going to look at next class, and today we're going to focus on just getting into the idea of multiple inheritance. So let's talk about it. Some programming languages support this idea of multiple inheritance. And multiple inheritance is having this relationship between a single class and multiple different parent classes, but it is still an is-a relationship. If you have a single class that inherits from multiple different parents, that single child class inherits everything that you would expect it to inherit from its parent class, but now it's inheriting it from multiple different places. So a child class, a single class that has multiple inheritance, multiple parents, it inherits all of the state from both parents, and it inherits all of the behavior from both parents. So everything that we would expect to get with regular inheritance, we get doubled up with multiple inheritance, or n-ary up. This is a language-specific feature. Multiple inheritance is not just something that you get with object orientation and with classes and the general concept of representing data this way. JavaScript, this is our most recent language. JavaScript kind of gives you something that looks like multiple inheritance in the form of mix-ins. When we were talking about JavaScript classes, class, my class, you can only extend one parent class. That's it. When you define a class, when you declare a class, you're only permitted to extend one class. You can take that class and you can add behavior to it at runtime. You can use that object.assign, and you can use this object that has methods and state in it, and you can just inject it into that class definition. And you can sort of get multiple inheritance that way, but this is defined at runtime, where multiple inheritance, as we're thinking about it, is something that's defined at compile time. In JavaScript, there's no compile time, but it's more like as we're reading through the file and getting the declaration of that class itself. So JavaScript doesn't support this explicitly, but we can sort of simulate it, like a lot of things that we can do in JavaScript. We can simulate the idea using mix-ins by adding behavior to a class after we've created it at runtime. Java, you well know at this point that Java does not have this idea of multiple inheritance. It's forbidden. We can have one single parent class and that's it. But we can sort of simulate multiple inheritance by using interfaces. So we can do this in two ways. We can have a class that extends another class, but also implements an interface. And then we can use both of those types to refer to that class, or all three of those types to refer to that class instance. But Java also just explicitly supports as many interfaces as you want. You can implement as many interfaces as you want. You're just permitted to do that. They don't have to be hierarchically related to each other. You just mark the class as implements and then give a long list of interfaces as you see fit, and it will be able to do all of those things. It can do all of those things that are defined in the interface. C++ is a language that's kind of like, hey, that looks like a great idea. Let's just hack it in. And it does that for everything. And so multiple inheritance, yep, we're going to just be able to do that straight up. This was not originally part of C++. When C++ was originally defined, multiple inheritance was not part of the language specification, but it very quickly got added, and this is just something that's been in C++ for a very long time, this idea of multiple inheritance. C++ is this language. Have any of you ever played Katamari Damacy before or seen what it is? Two of you are nodding your head. Many of you are shaking your head. You won't be able to hear the music, but Katamari Damacy is this game where, wait a minute, what? There's a Switch version of this. Okay, so I'm going to check that out. Katamari Damacy is this game where you are playing. I don't know what the character's name is. I always forget. But there's like the king of the entire universe. And there's a bunch of like really weird character names. But you're this little person, this little thing that's got this kind of strange oblong head. And you've got this sphere. And I'll skip ahead because this is just the intro. Here. You take this little character and you just. This is the whole game. These levels, and you just like this little person, you just fall around, and it's all bigger and bigger and bigger. And the goal of the game is often that the king gives you these tasks. You have to build a ball, a sphere, that's so many centimeters wide, and you can't collect big things until you make your ball big enough. So you have to kind of roll the ball around and like get little things, and your ball gets bigger and bigger things. And this is it. This is the whole game. And it's just levels and levels of like collect all this garbage from this ball. And the C++ code that I will let you watch the rest of this 4-hour gameplay of Katamari Damacy on your own time. C++ is this language that just, to me, is like, yeah, hey, that looks like a great idea. Let's just glom it on. Let's add it. Let's just build it in. C++ is a language that supports multiple inheritance. Java, again, as you well know, is a language that does not support multiple inheritance out of the box. Java, when you define a class in Java, allows only one parent class. Every class in Java has exactly one parent class. If you don't define a parent class, it's implied that you mean that your class extends extends object. Inheritance in Java is basically this giant tree. It's a massive tree structure that is rooted by object as a class. Everything extends from object, ultimately, when we keep going up the tree hierarchy. Java does allow you to have multiple interfaces, and we saw this when we looked at interfaces the first time, and we saw this when we looked at interfaces the second time. Java gives you the ability to define interfaces. We can define a class here called sub that extends another class called super, and we can then just give it a list of things that this class implements. The idea of an interface is that an interface specifies behavior. That's all it does. It just specifies behavior. That means that interfaces have method signatures for as far as we know about right now. What we're marking a class as being able to do when we say that it implements an interface is that it must have this method. If we refer to it by this type, we can expect to be able to call this method and it will be implemented. This is that can-do relationship. An interface only specifies behavior. It only specifies behavior. Interfaces, though, can also define behavior. And we saw this briefly in the form of default methods. Interfaces can define behavior. They can also define data, and I'm very intentionally not saying state here. They can define data, but they cannot define state. Let's take a look at this code. So I'm going to just really quickly write printable.java. This is a public interface. I've been messing with my VS Code. If you're looking at the back, can you see this? Yeah, thank you. Public interface printable. An interface in Java can define data. So I'm going to say in here, int terminal width is equal to 80. 80 characters wide is a good terminal width. This is effectively a public static final named constant. This is effectively public static final as a named constant. We don't have access modifiers. We don't put the static keyword on it, but it is effectively the same thing as public static final of that type. I can have default behavior here, default void print, and I can say system.out.println this, and I can use that. So I'm going to say this. I'm going to say class main implements printable. I'm going to say public static void main string args. I remember the first time I taught 1010, and this was a really long time ago when I was a grad student. And it was just like every class, public static void main string args, public static void main string args, public static void main string args. And then now it's in processing, and you don't see that until 1020. I don't know where I'm going with that, but that's what it is. When I've got this printable, I can say printable P is equal to new main. So my main method here is just like it's within this class. My main method does not define this behavior because it's provided by the interface that I'm implementing. I have a default method. And I can do things like p.print. I can say main is m is equal to new main, m.print. I can say system.out.println. The terminal width is, and because this main class implements printable, I have inherited the named constant from the interface. So I can say main dot terminal width. I can refer to that variable. I'm going to make this a little smaller. So this is effectively public static final. I can define behavior. I can define default behavior for classes that implement this interface. I can use that interface as a type. I can call methods on that. I'm going to give you a second to think about this. What is this in this context? Yeah. Yes, yeah. It's the object that implements it. It's the current object that implements it. Yeah. So if I run this, what I'm going to get back out of this is a couple of instances of main. They're different instances, like they have different at whatever, but they're different instances of main. There happens to be the class that implements it right now. If I added another class here, and I said class not main implements printable, and I'm not going to put anything in there. I'm just going to use the default behavior that's in this class, and I create an instance of not main. So let me add this here. P is equal to new not main, and I say p.print again. I can refer to that method because that class implements that interface. And if I run this again, I get not main. So this is just the enclosing actual concrete class implementation that that method has been inherited from, that default method has been inherited from. When I'm referring to this, I'm going to press dot here on my keyboard. And inside of this method, this exposes only the properties and methods that are on the printable type. So within that default method, we don't know anything about the other classes. We don't know anything about them. All we know is that this is something that has to extend object, and it has to implement printable as an interface. So the things that we get out of this are things that come from object, like clone equals hashcode toString get class. Terminal width comes from printable. Finalize comes from object. Notify comes from object. Notify all comes from object. Print comes from this interface right here. Wait and wait are both from object. So all we know about the type inside of this, when we're referring to this variable this, the state that this interface has is just, it's an instance of this interface. That's all we know about this. Let me see. Do I want to digress here? Yeah, I'm going to digress here for a second. So one thing that we talked about in JavaScript was duck typing. And duck typing is if it quacks like a duck and it waddles like a duck. If it waddles like a duck, then it must be a duck. And usually we're asking the question, can this object do this thing? Does it have this function that we can call on it? We can kind of do that in Java too. Shut down. This is not course material. Not course material. You don't have to take notes on this if you don't want to. If you are taking notes, I'm going to say this dot get class. Okay. that gives me the type that this thing is. So this is whatever this is, whatever the object, the current object is, .get class gives me the class that this thing happens to be. And on get class, I can do things like get method, okay? So I can ask for the methods that are defined on this class. And I'm going to ask for this first one. So this get methods gives all of the methods that are declared in the class. This one gives us the ability to ask for a specific named method. And I'm going to say it's called doStuff. I want a method that's called doStuff, and I want it to be a method that takes no arguments. So I don't put anything after the name of the method. I'm going to have to do a quick fix here, and I'm going to add surrounds with try multi-catch, okay? So for us to be able to do that, we have to catch two different kinds of exceptions that can be thrown in a Java method. I'm going to say method doStuff is equal to, I'm going to quick fix here and import method. Oh, come on. It's just control period, I think. Yeah, import method. Okay, so now we've got method doStuff. The variable that's called doStuff is now a reference to a method that's defined on a class, declared on a class. And now I can try to invoke that method. So to invoke the method, I say doStuff dot and then invoke. And what I have to pass to invoke is the object that I want to invoke the method on. So I have to give it an instance of the class that has the method that we've just asked for. So I have to say this. This is a method that we've previously said does not have any arguments on it. And I'm going to do quick fix again, and I'm going to add exceptions to existing catch clause, okay? So the catch now has gone off my screen here with the different kinds of exceptions that you have to catch. And this basically now says we can call doStuff on this. That's what that says. I can invoke that method on this object. And then in JavaScript, the way that we did that was type of this.doStuff is equal to function with no exceptions. Cool, that's it. Okay, thank you for listening to me digress completely off the course topic. Yes, okay. I can't really tell if this is meaning that Java is a good language or JavaScript is a good language, or if they're just both really bad. I'm going to delete all this. All right. So we've got this printable interface. We have this idea of what this happens to be within that class. We have named constants. We cannot assign these values. So within this main method, I can't say p.terminal_width is equal to 100. I can't change that. It's a named constant. I'm not permitted to make changes to that. This is kind of what we expect or what we know about being able to do with interfaces in Java. So far, we know that we can have a class that implements multiple interfaces. So we can have more than one interface attached to a class, because all we're really trying to say is that a class can do all of these different things that are declared within those interfaces. We know that interfaces have the following properties. They specify behavior. They are declaring methods. When we normally look at interfaces, they are filled with method signatures, and that's it. They're just signatures of methods that are saying a class that implements this will have a method that looks like this defined inside of it. We've learned that they can define default behavior. We can declare and define behavior within an interface. So not just declaring that something that implements this interface can do this, but also, hey, here is some behavior that you can use if you don't want to implement that behavior yourself. And we know that interfaces can include named constants. So we can put something that looks like an instance variable inside of an interface, but it's just public static final named constant. I'm going to give you like 30 seconds. Read this code. Think about it. And then I'm going to type it in. OK, I'm going to start typing this in. I'm going to call this file, I'm just going to put this in a new file, and I'm going to call it terminal printable. I'm going to make it an interface, and I'm going to put void print on it. So this is going to print to our terminal. I'm going to make a new interface here. I'm not going to put public because I'm going to put this in the same file. Printer printable. Print it out on your printer. And then I'm going to add a class. Implements terminal printable and implements printer printable. And Unikitty here has public void print. Looks good. No compile issues. Is that consistent with what you thought? Thumbs up? Thumbs down? Not consistent with what you thought? We've got two interfaces here, and we have one class that implements them both. The thing that looks weird about this right away is that both of these interfaces have the same method signature. They have exactly the same method signature. This looks weird. This looks weird. We've got two different interfaces that implement the same interface. Two different interfaces, I'm sorry, that have the same method signature. Let me do this. Public static void main string args. Unikitty is a class. Let me tab this back over so that it doesn't look like a total mess. Unikitty is a class that implements both terminal printable and printer printable. These two interfaces have only specified behavior. They have only stated that a class that implements these interfaces must have this method. That's all that they've said. That means that I can do things like terminal printable p is equal to new Unikitty. That's something I can do, and I can refer to this variable, and I can do p.print. I've got printer printable. I don't know. Bzzzt is equal to new Unikitty. And I can say bzzzt dot. That's a really bad name for a variable. Printer. OK, that's not imaginative, but printer.print. And I can call that method on it. And it's fine, because while both of those different interfaces say, hey, there's this method signature that matches this signature, that's all they say. That's all they say. So for this one class to implement both of these interfaces, it can just have that behavior. That's all we're saying by implementing those interfaces. Interfaces can have default behavior attached to them. Where before we were just declaring that these two interfaces had this method signature, you can call this method on objects that implement this interface. Now we've defined some behavior. We've said this is the behavior that this class should have if it doesn't otherwise implement this interface, if it doesn't otherwise define this method. And the goal here is basically, I want to have some default behavior so that I don't always have to rewrite the same code over and over again. I want to be able to satisfy this interface without having to write all of that code in a really painful way. So let's take a look at this. I'm going to comment this out for now. I'm going to comment that out for now. And because Unikitty no longer implements that interface, we can assign it to a variable of that type. So I'll comment this line out as well. Adding the default behavior to terminal printable here, default void print, and now I have to specify a method body for this, system.out.println this. So this is the same as the other printable interface that we had. And I'm going to delete this method. The purpose of having a default method is that I don't really want to have to specify it over and over and over again. So Unikitty doesn't implement printable. It doesn't implement this print method anymore, but because it implements this interface that has some default behavior, it works. And that's great. That's kind of what we hoped to accomplish. We get some output here when we print this thing. I'm going to put this back. I want Unikitty to be able to implement both of these interfaces. And now we're in a state where it doesn't compile anymore. It doesn't compile anymore. The issue that we've got here is that we've got a default method that is inherited. We have some default behavior that's stated in one of the interfaces that we've got. And there's another one, another interface that we're implementing that specifies the exact same signature. And trying to figure out which one is the correct one is a problem that Java has basically said, no, that's not my problem. I'm not going to figure this out for you. I'm just going to refuse to compile. Java solves this problem where we have multiple different methods that collide with each other by saying, if you want to implement both of these interfaces, you have to define the behavior yourself. You actually have to do that. So if I now say public void print, that's fine. It's fine. I've overridden, I've replaced the behavior that was stated in the default method in the interface itself. So I've completely replaced that behavior. So I kind of have to do this, system.out.println. And I'll just do the same thing. I'll just copy the code for now. I'll just copy the code for now, but I have to define my own version of this. I'm required to define my own version of this because the default method is there, and it collides with another interface that we're happening to implement in this class. Okay, so that's good. Let's extend this just a bit. I'm not going to type this in, but I'll let you read this, and I'm going to give you like, I don't know, 10 seconds, and I'm just going to ask for thumbs up, thumbs down. Is this going to compile? What do you think? Does this compile? No? Yes? No? I see thumbs up and thumbs down in the same row. So because we've got two different classes, two different interfaces that define the exact same signature method, it's effectively the same problem that we had here. We can't tell the difference between which one we're supposed to actually inherit. This works. This one doesn't work because even though we have this default method, we've got this collision with this other name that happens to be the same. This one also doesn't work for the same reason. We have two methods that have a signature that collide, and one of them has an implementation. This one has more than one has an implementation, but just because one of them has an implementation, it kind of says, I'm going to give up. You have to define this yourself. Classes that implement multiple interfaces. If we have a signature collision and more than one declare, so just straight up declare, no definition of behavior, they just straight up declare the exact same method signature, you just got to do what you were going to do anyway when you're implementing an interface. You just have to define that behavior yourself. If one or more define default behavior, and you have this name and signature collision between methods, then you have to implement that behavior yourself. Even though there is a default method, you don't just get that for free because the compiler doesn't want to try and decide what your meaning is. It doesn't want to try and make that decision on your behalf, so you have to make the decision yourself. When I did this, let me go back to my code here. When I did this, I kind of just copied and pasted the default behavior because sometimes maybe we do actually want that specific default behavior. Sometimes we actually do want that specific default behavior. We don't have to copy and paste it. You can refer to a specific default implementation using the name of the interface. So within this Unikitty class that I have here, I can, instead of saying system.out.println, I can say terminal printable, and then in a kind of unusual place, use the word super here, .print. This says I implement this interface. I implement this interface, therefore it is my super interface. It's my super interface, and I would like to call a specific method within that interface that has been defined on my behalf. This doesn't work the other way, so I can't say printer printable .super.print because there's no default method on that right now. If I had a default method, I could do that, but right now the state is that I've only got a default method on terminal printable. So we've got this idea of a super interface, and we can refer to that specific implementation. Referring to a specific implementation in a specific super interface by name is going to give us a bit of a taste of what we're going to have to do in C++ when we start to do multiple inheritance in C++. That gives us an idea of the kinds of things that we can expect to do. Interfaces can also define data. And again, I'm really emphatically saying they are not state. It's just named constants. We're not doing anything magical here. It's not going to get state attached to it. It's really just public, static, final, and then the actual thing that you've got there. It's just a named constant. That's all that this thing is. But we've got the same problem. When we had multiple declarations of a method, just the signature, just specifying behavior, there was no problem. We always had to define that behavior ourselves. When we had a default implementation, then we had to define it ourselves. We were forced to do it. The same kind of idea applies to named constants that are attached to interfaces. So let's take a look at this really quickly. I'm going to make a new file again. I'm going to call this importantnumbers.java. I'm going to make this a public interface, and I'm just going to take a shortcut. I'm going to copy and paste all this stuff. And I'm going to make these not public because they're just in the same file. And I'm going to make a main method in here. When I just implement important numbers, I can do things like system.out.println with numbers.py. That works, that compiles, because I only have one interface that I'm inheriting from that has that name. So it's just kind of added to me as a named constant that I have within my class implementation. This is the same thing as saying system.out.println important numbers.py. It's the exact same thing. These two lines are referring to the identical named constant data that we've got here. When I implement less important numbers on top of important numbers, because we have this name collision, it's unclear which one I'm supposed to get. Should I get something that's close enough, or should I get something that's a little bit closer? It's unclear which one I'm supposed to get if I just try to refer to this by my own class name. So the error here is it's ambiguous. This is a word that's going to come back and haunt us when we're starting to look at C++ with actual multiple inheritance. The actual named constant that we're trying to refer to here is ambiguous. It's unclear which one we're supposed to be inheriting, even though it is just a named constant. It's not any kind of state. The solution that we have is that we are required then to refer to the actual interfaces that specify those named constants. We can't refer to them through our own class name anymore. When we implement both of these, we're not permitted to do that anymore. This will not compile anymore. This doesn't compile anymore. These are edge cases. These are kind of absolutely edge cases. This is not something that you're going to be running into every day when you're using interfaces. We're just highlighting edge cases here. These are the kind of problems that you can kind of start to run into when you start to think about doing multiple inheritance with interfaces. All right. If you have a class that implements multiple interfaces, and you've got one of those interfaces defining and declaring data, so one interface has a named constant, the other one just doesn't have it, that's fine, no problem. That's just the named constant that we get, and we can refer to that. We inherit the named constant. We can refer to that using our own class name. If more than one declare and define the same name variable, so the same name variable as a named constant in both interfaces or n interfaces, you have to refer to the specific interface externally that you want to get that data from. You can't refer to the type that you are actually implementing in your class. So we can't do with numbers.py. We need to do important numbers.py or less important numbers.py. We have to explicitly say this is the one that we want to get, and this is the one that we want to use. We're okay so far? Good, good, okay. Java just doesn't actually support multiple inheritance. We knew this. This is not a surprise. But the way that Java does this is just to say, no, you can't do it. And the reason that Java does this is because, I mean, dealing with interfaces like this is kind of problematic enough. Extending this to classes and having state and actual behavior that's attached to multiple different parents, it's easier to just say, I disallow you from doing this entirely than it is to try and add rules to do it. And then we get C++. And C++ is like, hey, that looks like a good idea. So you can see in the top corner here that so it's one here. Little first one is like, the chicken just got I will let you watch the rest of this video on your own time, because you all watched the JavaScript video, right? Right? Yes? Okay, good. C++ is just like, yeah, okay, cool, let's do it. Let's have multiple inheritance. This seems like a great idea. Let's try to do that. I want to start this by not talking about multiple inheritance with C++, but instead by reminding you about kind of that abstract idea of what memory might look like for a class in C++. I don't want to talk about like heap space and stack space. I really just want to visualize this idea of we have a class, it has data, and then physically next to it is the data for the extending class. So let's start taking a look at what this looks like. Here I've got a diagram that's showing a relationship between three classes. I've got classes A, B, and C. I have implementation or instances of those classes, and I have pointers to those classes as variables. If we have this idea of C extends B and B extends A, so this is extends, I'm going to write this differently. I'm just going to write this out as class A. Class B extends A. And here we've got class C public B. So C extends B, B extends A. This is kind of our traditional hierarchical relationship between class instances. When we've got these objects in memory, the objects that we have created, either stack or heap allocated variables, the kind of top part of this is that metadata, information about the class that is contained within the next kind of glob of memory. When we create an instance of A here, what we get in memory is metadata that says this is an A and it's this many bytes long. And then what immediately follows that is all of the instance variables and behavior for that class. When we do the same thing with B, we create a new instance of B. We have metadata that's put into memory that says this is of type B. This is an is-a relationship, an inheritance relationship between B and A. And the ideal layout here is I'm going to take all of the stuff that A has in it, and I'm going to put it right here. And then I'm going to take all the stuff that B has in it. So all the instance variables for B are just going to come immediately after that. My goal for this is that I want to be able to assign these instances to pointers of the types that we've got. I want to be able to say that a pointer to A can point at an instance of A. I want to be able to say that. Because B is a subtype of A, I also want to be able to say that a pointer to A can point at an instance of B. I want to be able to do that. I want to be able to say something like A star A is equal to new B. I want to be able to say that. The best way for me to be able to accomplish that is to have a layout that kind of looks like this, where I take the top layer of the inheritance hierarchy, and I just put that at the top of memory for this object. And then immediately beneath that, I can put B. And what B would point at here is it might point specifically to this metadata that says this is an instance of B, but B itself kind of knows all about everything that's in A, everything that's public in A or protected or friend access in C++, which we might talk about this week, but I'm not 100% sure about that. We don't need to talk about it. B knows everything about A, so it's okay for it to be able to see all of A stuff. B knows everything about B, so it's okay for it to know everything about B stuff. Likewise, I want to be able to take an instance of C and assign that to A. And I do that by just putting A stuff at the top. A only knows as much as A has, B only knows as much as B has, and C only knows as much as C has. What you can kind of see about this relationship is that I'm taking all of the stuff that's defined within a class here, and I'm just jamming it into memory for that type that extends it. So I'm taking all of the stuff from B here, and I'm just jamming it into an instance of C. They're kind of identical layouts. They know everything about their superclasses. This is kind of what we have right now for classes that have this hierarchical relationship of C extends B, B extends A. Memory layout that looks like this. C++ gives us the ability to have multiple inheritance. So here's something that looks pretty similar, except I've taken this type hierarchy and I've changed it just a little bit. Here what I'm saying is that I have class A I have class B, they're independent of one another. And then I've got class C that extends both public A and public B. So I've got one class, it extends both of those different classes that we have here. I still want to be able to do things like an instance of C should be substitutable for A, and it should be substitutable for B. So in this other example that we've got here, when I'm saying I want to be able to refer to these multiple types, I want to be able to have a pointer to A and refer to an instance of B, or I want to have a pointer to A and be able to refer to an instance of C. I want to be able to replace instances of C into, or I want to be able to substitute them into instances of A. I still want to be able to do that here. I want to be able to do something like A star is equal to new C. I still want to be able to do that. I still want to be able to say B is equal to new C. I still want to be able to do that. This is a relationship. I should be able to do those things. I still want to be able to do those things. When we looked at the last example, the way that we were working with this was the idea that we've got this memory layout that has metadata at the top, and then we've got all of the instance variables and behavior that's defined in that class immediately below it. A and B don't have a hierarchical relationship anymore. They're not substitutable. I can't take one instance of one and replace it with the other. They're not related to each other anymore. They're related in the sense that they have a common child class, but they don't really know anything about each other. To accomplish this with C++ in a kind of memory layout here, I still need to be able to take all of A's stuff and jam it into an instance of this class. I still need to be able to take all of B's stuff and jam it into an instance of this class. I still need to be able to do those things. The order that I've got here, though, the order that I've got here kind of reflects what I've happened to have written down here. I'm going to write this a little bit bigger. What I wrote down here was class C extends public A and public B. The order that I have here kind of coincidentally matches that. But, I mean, I could just reverse them. I could. There's nothing really stopping me from doing that. The order here is something that is, this is defined by our compiler. What I want us to know right now is that an instance of C has all of these things in it. What I want us to know right now is that if I have a pointer to B, I should be able to, arrows are just going all over the place here. I should be able to substitute an instance of C. If I have a pointer to A, I should be able to substitute an instance of C. How that happens under the hood that's up to your compiler to do for you. You don't have to do that. We haven't had to do anything like that before. Your compiler has to solve this problem for you. But it has to give you the ability to have a structure that looks like this. Okay, I'm going to switch back to my slides. We've got this layout. We've got this structure that is, we have A stuff, which is data, state, and behavior. We've got B stuff, which is state and behavior. And we've got C stuff, which is state and behavior. One of the problems that we have with that is between these two things that we have on top. In Java, we say super. In JavaScript, we say super because we can have exactly one parent. In C++, which one is super? Which one's super? We don't have a super. There is no one superclass. We can't uniquely refer to a superclass. So in C++, we don't have super. So we have to refer to a specific parent name when we have collisions with behavior. This is also the responsibility of the caller of that interface, the caller of the method. It's not the child class itself that has to state which one it's going to get. So let's write a little bit of code. I'm going to write a little bit of C++ code. I'm going to brace for this fails to compile, but I'm pretty sure I'll be able to get it done this time. So I'm going to call this multipleinheritance.cpp. I'm going to spell inheritance right. That's helpful, but no thank you. I'm going to include, oh man, IOStream. Here I am just starting to write C. I'm going to include IOStream. I want to be able to print stuff in here. And what I'm going to do is I'm going to define 3 classes. I'm going to call them A, B, and C to be consistent with what we've been looking at. So I'm going to say class A. Class A has some public behavior, and that public behavior that it has is void print. So I'm going to be consistent with the methods that we're using in Java. I'm going to declare class B. I'm going to give that public behavior a void print, so the identical signature. Both of these classes have public methods that have the same name and return type. And I'm going to define class C here. Class C is going to extend public A and public B, but it's not going to have anything in it. It's not going to have anything in it because I really just want to be able to call those methods that collide with each other. We okay with this so far? We're good? Good. Okay. I'm going to implement these methods. So I'm going to say void A print. And A print is going to say std cout in A. And L void B print. And L, and then I'm going to declare a main method. And I'm going to create an instance of C. I'm going to make this a stack allocated variable, so I don't have a pointer, but the effect is the same, and I'll show the same kind of thing with a pointer, a heap allocated variable. The interface that we get from C, the methods that are available for us to call on C right now are what are inherited from our parent classes. The methods that we have inherited from our parent classes are both called print, and they both have a void return type. So there's a collision here. If we were doing this in Java, like we had been seeing before, because we have marked these as actual implementations of methods, they're not just method signatures. I haven't called this a pure virtual method in either of these classes. They are just actual implementations of a method. I want to be able to call some behavior on that instance of that class. I did not install the helpful C++ extension, so I'm not going to get helpful C++ help. But if I do clang, I'm going to do make multiple inheritance dot nothing. If I do this, the problem that we've got with this is that there's that word again. There's that word again, ambiguous. Yes, this class does have a method that's called print. It does, but there's 2 of them, and I don't know which one you mean. I don't know which one you're trying to refer to. I can see that this is a method. This is a method on C. There are print. But I get it from both parents. Which one should I actually invoke? Which one should I actually invoke? Our compiler doesn't know. It's not going to try and solve this problem for us. It's identified that it is a problem, but it's not going to help us try and solve this problem. The solution here is that me, as somebody who is using the C class, has to tell the compiler which parent I want to have invoked. The way that I tell my C++ compiler which parent I want to have invoked is to say C dot. This is very strange syntax. Everyone should be very surprised that there's very strange syntax in C++. C dot, and then the name of the parent, A, and then 2 colons, and then the name of the method that you want to invoke. So I want to call C's print from A. Oh, I didn't save it. That compiles. And if I run multiple inheritance here, I get in A. I get A's behavior from print. If I want to call C's other print implementation, I have to specify its parent name. So I have to specify which parent's inherited method I want to invoke. Now I'm going to save that again. I'm going to make it again. I'm going to run it again. And now I'll get in A and B. I'm calling each method from each parent separately. I'm going to do the same thing really quickly here. C reference. This is a pointer. I'm going to call it pointer. A pointer to C is equal to new C. The syntax is kind of the same thing, except we're saying pointer arrow a : print. It's weird syntax, but we're specifying the name of the parent that we want to refer to, pointer arrow B print, and that specifies the name of the parent class that we want to refer to. Printer, pointer. Thank you for shouting that out. There we go. And we get the same thing. It's just the same thing, but using an arrow instead of a dot. So we are required to specify which parent we want to call, which parent's method we want to call when we have multiple inheritance in C++, because referring to those methods is ambiguous. This is the code that we just wrote. Good, I'm happy about that. Let's move on. Now we're at the part where I'm going to stop, and what I'm going to leave you with here is where we're going to go next time when we have things like private int value, and then in both classes. We have collisions with names, with state and data. This is where we're going to go next class, and this is what will lead us into virtual inheritance. Okay, so we've got a couple minutes left in class. I just want to stop, and there were a couple of questions before class about the assignment. I'm going to do my best to remember what those questions were and then just answer them verbally for everyone. For the first question, I think, was about multi-file JavaScript. You don't have to do multi-file JavaScript for the assignment. You can just put everything in one file. The second question was, I forget what the second question was. I'm not going to call you out, and I'm not going to make you ask the question in front of everybody. I forget what it was. Another question that was asked was not about the assignment, but when will the midterm 2 grades back be back? They are about like 40% marked right now, and we will get them back to you before the last day of classes, so before the final exam. Oh, the other question was about a stack, using a stack for parsing the Newick format. I said in class last time that you could use a stack to do this. Like, that would be a completely valid way to parse a string, to parse something that's a regular structure like this. I would advise you not to use an actual stack implementation to do this, though. That's overkill. We're not expecting you to implement a stack for this assignment. The only data structure we're expecting you to actually implement is a tree. You're traversing a tree and using a stack, but you're not actually going to implement a stack. To parse the Newick format, I would suggest that you just use a counter to count how many parentheses you've seen, and then string on JavaScript has a split method. So you can split on the comma that you found that is the one that separates the two subtrees for the root node that you're currently looking at. Yeah, are there any other questions about the assignment so far? I know everybody's like assignments in 2080 and 2280 are due tomorrow. Yeah, I know everybody's working on that. Next week, I'm not going to give time for questions on Thursday, but next week on Tuesday, again, last minute, but I'll give some time for questions then if there are no other questions about this right now. Yeah, at the back. The midterm. The final assignment mark, there's no way our graders can finish that in 2 days. I would expect that the final exam and the final assignment mark will come out approximately at the same time, but we won't be returning the final exams, the just normal standard operating procedure, but we will definitely be returning the assignments that you submit for JavaScript stuff. Any other questions? All right, cool. So at this point, you should be able to use interfaces in Java to simulate multiple inheritance. It is explicitly not multiple inheritance, but it gives you something similar. It gives you something similar to what you get in C++. You should be able to identify problems in Java code related to implementing multiple interfaces. Really specifically, these were, we have default behavior and we have a signature collision, or we have stated the same variable name as a named constant. You should be able to visualize what memory might look like in a C++ program with standard one-parent inheritance relationship and multiple inheritance relationships. And you should be able to call superclass specific behavior in a class that uses multiple inheritance in C++. Thank you all for coming out, and I will see you all on Thursday. Bye, everyone.